In November 2023, mission controllers at NASA's Jet Propulsion Laboratory received an alarming transmission. Voyager 1, humanity's most distant space probe, stopped sending readable science data. Instead, its telemetry fractured into an endless, repetitive loop of binary code. The spacecraft had effectively become a zombie. Diagnosing this failure presented a massive logistical hurdle. The probe is currently over 15 billion miles away. At that distance, a single radio signal takes 22.5 hours to cross the void. Every time engineers sent a troubleshooting command, they had to wait 45 hours just to hear a response. The team was working with ancient technology, trying to debug a set of 3 onboard computers built with 1970s architecture. Finding a fix was a race against time. Engineers at JPL began a desperate attempt to salvage the probe before it drifted into permanent silence. When Voyager 1 launched in 1977, it embarked on an expansive journey to study the outer solar system. Carl Sagan realized the probe's velocity would eventually throw it out of our solar system. He convinced NASA to attach a message in a bottle. They created the Golden Record. It contained spoken greetings in 55 different languages, the ambient sounds of wind and rain, and a 90-minute curated selection of human music ranging from Beethoven to Chuck Berry. The Golden Record transformed the probe's identity. It was no longer a package of scientific instruments, but a physical representation of our species designed to outlast its creators. This profound cultural weight is why the JPL team refused to abandon the mission, driving them to attempt unprecedented remote surgery from billions of miles. In 1979, Voyager 1 arrived at Jupiter and provided the first evidence of active volcanism beyond Earth. It captured 9 plumes erupting from the moon Io, shattering the long-held assumption that moons were merely geologically dead, cratered rocks. A year later, it reached Saturn. The probe's cameras resolved the planet's rings, with enough detail to reveal a system of braided structures and tiny shepherding moons. By 1990, the spacecraft had completed its primary planetary flybys. At Carl Sagan's urging, mission commanders turned the camera array back toward the inner solar system to capture a final portrait of the planets. The most striking image from that mosaic caught Earth suspended in a scattered ray of sunlight. From nearly 4 billion miles away, our entire planet appeared as a single fragile pixel. Voyager 1 mapped the outer planets, then turned its lens back to force a confrontation with our own isolation and fragility in the cosmos. Back in 2024, the JPL team needed to see inside the machine. They transmitted a poke command to Voyager 1, forcing the onboard computer to dump its raw memory directly back to Earth. When they decoded the dump, they found the culprit. The flight data subsystem, the computer responsible for packaging data before transmission, had a hardware failure. Exactly 3% of its memory was corrupted, likely due to a single failing microchip. Physical hardware replacement is impossible at 15 billion miles. The team devised a software workaround to bypass the dead chip. Engineers sliced up the essential flight code into fragments, tucking those pieces into empty, functioning sectors scattered throughout the rest of the memory bank. They then rewrote the system's internal pointers, ensuring the ancient computer knew exactly where to find the newly relocated fragments. On April 20th, 2024, the control room finally received a clean signal. After 5 months of silence, Voyager 1 resumed sending clear, readable science and engineering data. Using 1970s code and enduring massive communication delays, engineers successfully repaired a broken machine in deep space. Today, Voyager 1 is sampling the density of the interstellar medium outside the protective bubble generated by our sun. This line graph plots the spacecraft's available power over time. The probe runs on a decaying plutonium source, meaning it loses about 4 watts of electrical generating capacity every single year. To keep the central computer from freezing, engineers employ a protocol of strategic deactivations. They intentionally shut off background heaters and scientific instruments to conserve the dwindling power supply. In April 2026, this math led to the deactivation of the low-energy charged particles instrument, ending nearly a half-century of continuous service. The engineering team is now engaged in a grim triage, systematically trading away scientific instruments to buy the spacecraft a few more years of survival. The timeline is unavoidable. Sometime within the next decade, Voyager's power levels will dip below the absolute minimum required to transmit. The probe will go completely dark. But the death of the electronics is not the end of the mission. Fastened to the side of the bus, the golden record will remain intact in the vacuum. Voyager 1 will continue outward as a silent monument. It will drift through the Milky Way for billions of years, unaffected by the eventual death of our own star. Even after its mechanical death, Voyager 1 succeeds in its ultimate mission, ensuring that the evidence of humanity's existence will outlast the Earth itself.